Okay, 7.3. We're just going to review the meanings of converse, inverse, and contrapositive. So for converse, we are just going to basically switch the hypothesis with the conclusion. I'm going to try to type this since my smartboard is not working very well. So, if a triangle, I can type, has two acute angles, then it is right. Okay, let's just make this all a little bit smaller. How's that? That's better. Now, that is for the converse. Forgot to label it. Now, for the inverse, we're basically just going to negate the first statement. If a triangle is not right, you don't have to capitalize it obviously, then it does not contain two acute angles. And then the contrapositive basically takes the converse and negates that. If a triangle does not have two acute angles, then it is not right. And that's it. Let's do it one more time. So we're just going to switch it first. If I do not go shopping, there is ice on the road. Again, that is my converse. My inverse, remember, I'm just going to negate the first statement. So if there is not ice on the road, then I will go shopping. And there's no capital not because the first was not go shopping, now you will. And then the contrapositive, remember, we're just negating the converse. If I do go shopping, because we said not go shopping, there is not ice on the road. Okay? Hit pause if you need to catch up. Alright, now we're going to use these points to find slope or measure. So for number one, we're finding the slope. So A and B, we're going to use these 2 points. Remember, it's y minus y over x minus x. And just for review, because we're going to be needing to use these properties this lesson. So we're going to say y minus y, 5 minus 1, over negative 2 minus a negative 5. So 5 minus 1 is 4, and negative 2 plus 5 is 3. So my slope is 4/3. Now the distance from A to C, remember the distance formula, does not look like a squiggly line. The distance formula is the square root of x minus x squared plus y minus y squared. So I need my 2 points, A and C. So square root -2 minus 3 squared plus 5 minus 2 squared. That's even too bad for me. Square root -2 minus 3 is -5. Now be careful here. Remember, negative number squared is always going to be positive. So -5 squared is 25, just like 5 squared. And then 5 minus 2 is 3, squared is 9. So 25 plus 9 is the square root of 34. Now, there's no perfect number that goes into that, perfect square number, like 4 or 9 or 16. So that is the exact answer. If we ask for the decimal answer, we'd say the square root of 34 is 5.83 or just 5.8. So remember, this one is actually called the exact answer because the decimal is rounded, not exact. So the radical is actually exact. You don't have trouble with that concept. Okay, 2 new theories that are really just the opposite of what we've already done. In the previous section we said if we have a parallelogram, opposite sides and opposite angles are equal. Well, the converse of that, remember we just switch hypothesis and conclusion, is if we know the sides, opposite sides are equal and the opposite angles are equal, then we have a parallelogram. So just go in the other direction. So an amusement park ride has a moving platform attached to 4 swinging arms. The platform swings back and forth, higher and higher, until it goes over the top and around in a circular motion. In the diagram below, AD and BC represent 2 of the swinging arms, and DC is parallel to the ground, which is line L. Explain why the moving platform AB is always parallel to the ground. Okay, so that was going away here. So line L is the ground, and we know that DC, okay, so we know that this piece right here is always parallel to the ground. And the question is, how do we know that AB is always parallel to the ground? Well, we know that because those opposite sides are equal, and those opposite sides are equal, and since both opposite sides are equal, they're congruent, that means we have a parallelogram. That's it. Since opposite sides are equal, we have a parallelogram. And therefore, AB is parallel to DC, which is parallel to the ground. Okay, example 2. For what values of x and y is quadrilateral PQRS a parallelogram? Well, if it's a parallelogram, this has to be equal to that. So we just say that. 2x minus 1 equals x plus 9. I'm going to subtract x from both sides. I'm going to add 1 to both sides. And that gives me 10. Again, the beauty of math is you can plug this in and find out 10 plus 9 is 19. 2 times 10 is 20, minus 1 is 19. We're halfway there. Now, since we know x is 19, we're going to substitute that in right here and find out that this side, QR, is 26. And there's really no math now, except to say that y is also 26, because opposite sides have to be equal. Okay, now, a new twist on what we already know. We said if we know both opposite sides, pairs of opposite sides are equal, or both opposite angles are equal, we have a parallelogram. Well, if we know that one pair of parallel sides, or one pair of opposite sides, is both parallel and they're congruent, that's all we need to have a parallelogram. So if 2 opposite sides are parallel and congruent, we have a parallelogram. And then the diagonals converse. We said before, if we had a parallelogram, the diagonals bisected each other. Well now, if we know the diagonals bisect each other, we have a parallelogram. Again, just going the opposite direction of what we already knew. So, this doorway shown is part of a building in England. Over time, the building has leaned sideways. Explain how you know that SB is parallel to TU. Okay? Well, if we look at ST and we look at VU, ST and VU are parallel by the triangles and congruent by the hash marks. Since opposite sides are both parallel and congruent, we have a parallelogram. And if we have a parallelogram, that means SV is congruent to TU. So we use our new theorem to make it a parallelogram, to name it a parallelogram, and then that lets us know the other sides are equal. Okay, so for what value is this quadrilateral a parallelogram? Well, we see here that this and this are equal. That means that CE and DF have bisected each other. Well, DE has bisected CE. Sorry, DF has bisected CE. So therefore, if this is also bisected, and these two are equal to one another, we would have a parallelogram. So we just do that. We're in control. We say we want them to be equal so that we have a parallelogram. So I'm going to subtract 5x, which gives me negative 8 equals negative 2x. And when I divide by negative 2, I get 4. And again, the beauty of math, if I plug 4 in for x, I get 4 times 3 is 12. And 5 times 4 is 20. And 20 minus 8 is 12. So I have proven those two parts congruent. Okay, now these problems are a little bit of work, but they're not too bad. We can do this a lot of different ways. We want to prove this is a parallelogram. So basically, the quickest way is just pick two pairs, two sides, opposite sides. So you do whichever one you want to do. Wow, that's horrible. Let's say we wanted to take, that's horrible too. This board does not like me. This line segment and this line segment. If we can prove these two congruent and parallel, meaning the same slope, we know we have a parallelogram. That's all we need to do. Okay? So that means we need to find the slope for both. So for A, D, okay, the slope is going to be y minus y over x minus x, which is 3 over negative 3 or negative 1. Now, here's the beauty of this. Remember, when it's on a graph, you can also just count 1, 2, 3 down, and 1, 2, 3 right. That is a negative 1 slope. Okay? So you actually don't have to do the math if it's on a graph, which I'm going to do up here. So 1, 2, 3, 1, 2, 3. I've just proven that BC has a slope of negative 1 also. So I'm halfway there. Now I just have to prove congruence. And this is the last part. Okay? So the last part, I have to do that distance formula. So for AD, I'm going to do the square root of x minus x squared plus this y minus y squared. And what that's going to give me is negative 3 minus 0 is negative 3. squared, remember, is positive 9. And 3 minus 0 is 3. Squared is positive 9. So that's the square root of 18, which can be reduced, but let's wait there. Now I'm going to do the distance of BC. So for BC, I'm going to do 2 minus 5 squared plus 5 minus 2 squared. And hopefully you can see where this is going. Okay, negative 3 squared. Let me just go right to the numbers. Negative 3 squared is 9 plus 9. Well, look at what we have here. Square root of 18. I do not have to reduce that, even though I'm going to for practice. Perfect square, this breaks down to 9 and 2. So this becomes 3 square root of 2. Or I can turn it into a decimal. But square root of 18 is square root of 18. So I have proven that opposite sides are both parallel and congruent. Therefore, I have a parallelogram. And that's all I need to do. That's it.